Alrighty, hi there, Mr. Biggers here, and today we're going to be doing our Module 2, Lesson 4, Day 1. We're going to solve systems of equations graphically. Today's standards is wrong, so you can cross that out. I apologize about that. So today we're going to learn about solving systems of equations in two variables by graphing. So we just want to talk about some different things here. So you can see that we have two equations that are graphed in this first example. They have one solution. So when two graphs intersect, it has a solution. So this would mean that it's consistent. So as long as it has at least one solution, it's consistent. And it's independent because it has exactly one solution. So the way I remember this is systems of equations are independent if they're two separate lines that are coming together at one point, okay? The system on the next one. Technically here, you have two lines, okay? You can only see one because it's exactly the same line. So if they're exactly the same line, they're going to be consistent because they are consistent with one another. The same thing is true as long as there's an answer. If there's an answer or the lines intersect, it's consistent. These lines are dependent because they are the same. They're dependent on each other. So the way I think of this is like if you're dependent on your parent, you're going to go along with what they do. You're going to ride with them in the car, that sort of thing. So you're going to go along with them. These lines are dependent on each other. Okay? And the last one here is inconsistent because there is no solution. These are known as parallel lines or lines that will never touch. They're inconsistent. This is a review from Algebra 1. Okay? So example 1. We want to classify systems of equations. We want to determine the number of solutions that the system has. Then state whether the systems of equations is consistent or inconsistent. So we need to figure that out. Or whether it's independent or dependent. So we're going to solve each equation for y. Luckily, they already did the first one for us. And the second one here, all we have to do is add y over to the other side. And then you get 3x equals 7 plus y. And then we can minus 7 over here. So those cancel out and you get 3x minus 7 is equal to y. So y equals 3x minus 7. These are the same equation, which means they are going to be the same line, okay? Now remember, the same lines, it's not even parallel, it's exactly the same line. So exactly the same line is going to be consistent and dependent. Consistent because they have at least one answer or they touch at least one time, and dependent because they are the same line. So that would be those, okay? So number of solutions would be infinitely many. Infinitely many because they have the same, they are the same line. Okay, so example 2, solve a system of equations by graphing. So this requires you know how to graph points. What I would recommend doing is you can graph them in y equals mx plus b, or you can graph them using the intercepts. I'm going to go ahead and do y equals mx plus b, so that way we can see what their slopes are. So this one, if you solve for y, is going to end up being... Let's go ahead and add y to the other side. So you get 5x equals y plus 3 minus 3 minus 3, 5. So you're going to get y equals 5x minus 3. That would be your equation for that line. And if at any point you need to pause this, rewind it, feel free to do so you can see that. This one's easy. You just add x over to solve for y. So you would get y equals x plus 5. So we can graph both of those. If you look here, the y-intercept, -3 on the first one. So they would start down here, -3. And then it's up 5 over 1. So up 1, 2, 3, 4, 5 over 1. So that would be the point if I counted that right. So yeah, up 5 over 1. And then the slope on the next one, or the y-intercept on the next one, is 5. So they're going to start at 5, and the slope is just 1 over 1 because it's 1x. So up 1 over 1, up 1 over 1. So you can see that their solution here, right there, appears to intersect at 1 point, and the coordinate of that point would be the x is 2, and the y would be 1, 2, 3, 4, 5, 6, 7. So that would be your answer. 2, 7 is the solution of that graph. So that's how you solve a system of equation by graphing. So we have a check here. I want you to go ahead and pause the video, try this out, see if you can figure it out. I'm going to go ahead and do it. So I'm going to do this by solving for y really quick. So minus 14 to both sides, so I can get that. And then, so that first one's going to become y equals negative 7x minus 3. And then I can quickly do the next one. So 8x minus 4y minus 24. Going to go ahead and add, or minus the 8x over to the other side. So it's going to be minus 8x minus 24. And then divide everything by negative 4. And then that one's going to end up being y equals 2x plus 6. All right, so those are the two equations that we're going to graph. And then we're going to see where they intersect to find their solution. So I'm going to start with this one. You start at the y-intercept, which is negative 3, and the slope is down 7 over 1. Well, you can look, I can't go down 7. So what I'm going to do is go up 7 and then over 1. So that's what I'm going to go ahead and do now. So up 1, 2, 3, 4, 5, 6, 7 over 1. Those are the only 2 points I can fit on that graph, okay? And then this one here, you're going to start at positive 6. So I'm going to go up 6. So 1, 2, 3, 4, 5, and 6 would be right off the graph here. And then the slope is up 2 over 1, which if you look here, we're off the graph already. So I can't even do that. So I'm going to go backwards. So down 2, backwards 1. Down 2, backwards 1. Down 2, backwards 1. And then we should be able to see where these two graphs intersect. So if I go ahead and graph them here, I've got this line, and I've got the other line we'll do in blue. We can see their intersection. And if I did that correctly, this should actually be their intersection because you can see those green points are just a smidge off. So if I can edit that, I will. There we go. Perfect. So that should be that red line. So that intersection is right there. The point of that intersection is the x is negative 1 and the y would be 4. So that's your solution. Hopefully you got that when you graphed it. All right, moving on to the next thing here, solving a system of equations. It's pretty much the same thing. So to save us the time, these equations, actually no, we need to solve them for y. So first one I'm going to solve for y really quick. It's going to be 2y equals negative 7x plus 16. Divide everything by 2 really quick, and then that first equation is going to end up being this. So that is slope-intercept form. The next one, we need to do the same thing. So it's going to be negative 6y equals plus 21x plus 24. Divide everything out here by negative 6. So that's going to end up being y equals negative 21 over 6. Both of those are divisible by 3. So I'm going to reduce it to 7 halves minus 8. Or wait, 24 divided by negative 6, I'm sorry, is negative 4. So those are our two equations. So if you look here, both of the equations have the same slope. They have the same slope, and they have different y-intercepts. So these equations represent different lines. Different lines, and they're also parallel. okay? And there is no solution because they never intersect. So these lines are not dependent, so they are independent lines. Actually, they're not even independent because they don't have a solution. And they're inconsistent because they don't have a solution either. So those are your notes. Make sure you get those. And your assignment details are going to be on the back. So it's not actually Alex's assignment. You're going to use the notes to help with the assignment on paper. You want to do all the problems and attach a clear image, of your paper assignment to Canvas. Show all your work for credit. And this is due at 3:17 tomorrow. Thank you.